Okay, so basically I did my video on inverse functions, and the inverse function is, in my own words, basically the opposite of a regular function, and the inverse relation is kind of flipping the x and y values around. So the x values are on the bottom and the y values are on top. And when you're using addition, the inverse of a number would be basically the opposite of that number. For example, 7 the inverse would be -7. If you have 4, the inverse would be -4, and 6, the inverse would be -6. When using multiplication, the whole number is basically put over 1, so you would just flip those two numbers around. For example, if you have 7, it would be 1/7. If you have 8, it would be 1/8, and if you have 3, it would be 1/3. But when you're graphing the inverse relations, like I said earlier, you switch the x and y factors. So if you have a table that says the x values are 2, 4, 6, 8, and 10. The y values are 1, 2, 3, 4, and 5. The inverse of that would be x 1, 2, 3, 4, 5, y 2, 4, 6, 8, 10. And this is kind of a view on how the graph should look. They should meet at one point. They're kind of the same. Yeah. And some 3 example problems I did for inverse functions would be if fx equals 3x, the 3 and the x are times together, so you just divide that to get the function. So it'd be f minus 1x equals x/3. But if you have a function that says fx equals 3x and it says x equals 3, all you do is substitute 3 in for the x, which would be 3 times 3, which is 9. And you have an inverse function that says fx equals x/2, and then it says the f minus 1 is 8. You will plug that 8 in for the x on top, and you would divide that by 2, and that will get you your answer, which is 4. And so basically, wrapping it all up, inverse functions are the opposite of the function that you're given, and inverse relations is kind of like the same thing. If you have a table and it shows the regular table, the inverse table would be just those numbers flipped around. So the bottom would be on top and the top would be on bottom. And that's it.